So right now we're on grind 75, week 5. Problem number 8 is called sort colors. So let's see what that's all about. Given an array nums with n objects colored red, white, and blue, right, red, or blue, sort them in place so that objects of the same color are adjacent with colors in the order red, white, and blue. We will use the integers 0, 1, and 2 to represent the color red, white, and blue respectively. Okay. You must solve this problem without using the library sort function. Okay. All right, so we got a couple of examples here. And then n is equal to nums.length. Okay. There's going to be between 1 and 300 entries. And we have 0, 1, and 2 for our numbers. Okay, that makes sense. Follow up, could you come up with a one-pass algorithm using only constant extra space? Maybe. Let's see if we can solve it first. Okay, first step in solving it is to record the problem. This was, which number? 75. All right, so we put it right here. Like that. 0075, sort colors. I gotta create the file here. Because I work, so I can't just devote my entire time to watching Rust streamers, unfortunately. Oh, this is sorting in order, so we don't actually have. There's no return value. Okay, all right, it's sorting in place. Sorry. So there's no return value. So let's just make sure it builds. All right, so let's go test mod. Test. Example 1. And what we're going to do is say let mod, because it's mutable, right? I mean, we're going to sort it in place, so we have to see nums equals factbang this. And we're going to say sort colors nums, right? And then we're going to just assert that expected, which is factbang 001122 is equal to nums, right? And that should fail. Oh, and it fails for the wrong reason. Pub struct solution. What do we got here? Test. Oh, right. Solution : Okay, so good. So we're actually, we have a failing test here. This we can ignore because we're about to write it. So I mean, the obvious solution or the straightforward solution. So, right, all we need to do is write a sort. And we could just make a simple sort just to see. We have 300, up to 300. So if we did like, maybe we could do, since we know there's only 0, 1, and 2, what we can do is kind of cheat and say, okay, let's just keep track of each count of each value, and then we can say for n in nums, count of n. I think that's yeah, plus equals 1. Oh, as u size, right? We have to as u size it whenever we index into array, and then this will give us how many of each there are, right? And then all we have to do is fill those in for index count, int count. Ooh, is that going to work? I wonder if that'll work. Let's see. Does this shadow the other one? Oh, count iter enumerate is what I meant. That's a usize, and that's okay. So maybe that'll work. And then we can just say nums of idx is equal to, oh, no. We're going to need another for I in O. Okay, so we need another value, right? Let mut pos is equal to 0 for I in 0.idx. Nums of I plus pos is equal to, oh no, to count is equal to idx. So this should be color then, right? Color and count. And we don't need that, and then we just say pos plus equals count, right? This kind of does it. It's a little okay, as you I32. And it still doesn't like that. Oh, because I did this here? Really? But this should be, okay. If I re-reference it here, then this becomes a double, right? No, it still doesn't like that. Maybe I can just say nums iter here. And then what is n? N still is a star. Okay. So now the test pass. Let's do the second one. ex2. We can grab these lines, put them here, and this is just 201, and this is 012. Right? And does that test pass? It does. This seems like an awkward way to do it because we have to make 2 passes over. Oh, that, okay, yeah. That's why I said, can you come up with a 1-pass algorithm? And in the back of my mind, I'm remembering a Dijkstra algorithm that does this, so let me look that up. Doesn't iter have a sort function, or are you trying to manually sort it? Oh yeah. So yeah, I could just say return nums.sort, right? But the idea is we're trying to solve this problem without using the library sort function. So we have a 2-pass solution here, and I think there is a 1-pass solution if I'm remembering correctly. But let's try this out. Let's give this a shot and make sure we don't run into time complexity issues with this. Okay, so that was accepted. But I think there's, let me look it up. I want to keep this guy here, right? Because this is generally useful. Dijkstra. Not his searching algorithm or his what is it? What do you call it? But he had a color sort for this exact, oh, Dutch national flag problem. Okay, let's see what that is. Let me make this bigger so it's easier to read on Twitch, although this is huge for me. All right. So, okay, so we have pseudocode here for it. Right, so yeah, this makes sense, right? You start from the back, you have one pointer at the back and you have one pointer at the front. And as you work your way from the back to the front and the front to the back, you can flip numbers back and forth. Because if you have a 2 here, you can flip it to the end. If you run into a 0 here, you flip it to the beginning. And then 1s kind of fall out from that. So let's see if we can implement this as part of our solution here. What should we do with this one? Let's just underscore it. Pub fun sort colors nums. Right, so we have this here as our reference implementation, right? And then we can use this as our, oh, I can't move this over. It's just, there we go. Yeah, so you can hide that. Perfect. All right. So let's just follow the rules here. Let mut I equals 0. Let mut j equals 0. Let mut k equals size of a minus 1, nums len minus 1. That's easy enough. And then, so we say while I is less than or equal to, or j is less than or equal to k. Right, so k looks like it's going to be the thing that's coming from the middle, from the end. And I guess, comes from the beginning. Yeah. Right, and then j is going to point to the first one. So I starts with pointing at zeros, k starts at pointing at twos, and then j has the ones. And we need to bump our j up to find that. Okay, so the first thing we do is we say if, let's use Rust, match nums of j. Right, because it's either going to be 0, 1, or 2. So if in the case of 0, we're not going to do this quite. Actually, this is it, right? If it is less than mid. I don't know what mid is meant to be. Oh, mid is a value. Okay. Okay, so this makes it so that you can use any 3 consecutive numbers or any 3 non-equal numbers, right? Because it's either less than mid or greater than mid or equal to mid. So 0 is less than mid, so we're going to handle the less than mid case here. Nums swap of I and j, and then we increment I and j. If it's a 1, that means it's equal to mid, so we're just going to increment j. And if it's a 2, then it's in the case where it's greater than mid. So we will do nums swap j and k, and then subtract 1 from k. So k works its way from the end towards the beginning, and I works its way from the beginning towards the end, and then j will just bump up. It will always be the first one. And then, of course, we need to have an escape clause here. Or maybe we can just panic. Panic, invalid. Sorted order. So let's see if that builds. Of course it doesn't, because I messed this up. It doesn't go like this, it goes like this. Yeah. So that was straightforward, right? Let's copy paste that in. Boop. Let's go here, right? Close. We can paste that in here. Boop. So this is the Dijkstra Dutch flag problem. Dutch national flag algorithm, let's call it. Here. There we go. That way I'm not plagiarizing. If you cite your sources, you're not plagiarizing. Ooh, runtime error. What did I get wrong? Index out of bin. Oh. Ah, look at that. Okay. So that's surprising because the algorithm usually is meant to be able to handle len is 1, so k should be 0, j is less than or equal to k. What line number is it complaining about? Well, let's add this as a test and then we'll see, right? Like this. Fail 1. We do that, and we do that, and then we erase all those, and then we should get, here we go, line 21. Oh, okay. Right, so in this algorithm, k is allowed to go negative because it doesn't matter, because at that point j is going to be less than k and we'll exit. So we just have to put a little, yeah, we'll just say if k is less than 2, break. How's that? Does that work? That should solve it. Yeah, okay. Let's just throw that in here. Right. Same change. And let's see what we got. All right, perfect. Beats 84.13, beats 14.29. Just the way I like it. Git status, git add source, git commit dash m problem 75 sort colors. Git push. Okay, so that was a good warm up, and now I want to start playing with Bevy again. I want to get back to the that's AOC lib. There's lib. Right there. Perfect. All right.